So today we are looking at 2.3 day 2 and talking about a few examples related to characteristics of graphs. In the first part of 2.3 we mentioned the idea of end behavior, and so what we're going to do now is take some other characteristics that will allow us to combine with end behavior and do some graphing that is, basically just sketched by hand rather than relying on the calculator. So this is more characteristics of graphs. And first thing that we're going to look at is what's called multiplicity. That's going to be mainly the focus for this lesson for 2.3 day 2. Multiplicity refers to the number of factors for a zero, or number of factors for any given polynomial. So you'll see what that means when you look at this example. So we have right here a polynomial in factored form, and you'll notice that we've got a couple exponents up there. That has something to do with the multiplicity. Now if you were to make the exponent on this first one, you could say that that's a 1, just to be able to comment on the multiplicity here in a little bit. So we've got these three different factors and they have zeros. The zeros that go with them for x plus 4, it's -4, because that makes that factor 0. 2 makes this factor 0, and -5 makes this factor 0. So that means that these are the set of zeros that we have for this function. Now the other thing that we're looking at here is multiplicity. Now multiplicity is just how many times we have that thing appear in the function. So if it's got an exponent of 1, we say it's a multiplicity of 1. We say it's a multiplicity of whatever exponent is up there on that particular factor. So in and of itself, this wouldn't be all that useful, except that we're going to help figure out a little bit of some of the characteristics of graphs to maybe predict what will happen with certain graphs. So here is what multiplicity means for functions. So we have odd multiplicity and even multiplicity are the two different possibilities, because they're all going to be whole numbers. So we're saying that if a 0 is an odd multiplicity, then what happens is that at that particular 0 on the graph, at the x-intercept, it will cross the x-axis. So it'll cross through the x-axis if it is an odd multiplicity. Even's a little bit different. When we have even multiplicity, then the graph where it has the x-intercepts will bounce, and so it'll come down and it'll touch it in one spot and then it'll bounce and go the other direction. So we'll see how that works by looking at some specific examples on the graphing calculator. So I've got this here. We have x plus 2 squared, and I've got that entered into my graph. I graph it. What should happen according to these multiplicities, if it's even, it should bounce off of the axis. So we graph it, and you see that right around here it does just come down, touch it in one spot, so it bounces off the axis. We might try to see if this pattern works, if we can change the exponent and see if it does what we expect. If it's an odd multiplicity like this one would be, then we'd expect to see it cross. So now we graph it, and it does in fact cross. And we can go back and forth. We can just keep upping the number, upping the exponent, and you'll notice that one bounces. It's even. We could go back to odd, and we would expect it to cross, and it does. So you can test that out as you like and just see if that holds true for every time, so that you don't have to necessarily just take my word for it. But that is the basics of multiplicity, and we're going to use those in the next example to help us sketch a graph by hand.